All right, this is Unit 9, Day 5, and today what we're going to do is determine the lateral and surface area of different figures. This is the first day of 2 days that we're going to talk about lateral and surface area. Okay, reviewing some of the things that we talked about last semester. First of all, we have a rectangular prism here, and there is a face. Okay, that's the flat surface, so you see the face right there. This is a face, basically all the sides of the figure are faces. Then we have edges, and the edges are what connects the the faces together. So you can see there's an edge there, there's an edge there. Basically what it is it's a segment. And the vertex is the corner. Okay, the point that intersects three or more faces. If you notice, this vertex right here connects the bottom face and these two side faces. All right, last semester we also talked about prisms, but let's talk a little bit more about them. Prisms have two parallel congruent polygonal bases. Okay, so in this case it's a triangular prism, that's why we name it for its shape. It has a triangle for each of the bases. Notice they are parallel and they are congruent. The parallelogram faces, well in this case it looks like they're more rectangles, but remember that rectangles are also parallelograms. Then we have a cylinder. The cylinder has two parallel congruent circular bases, okay, and the curved surface connects the bases. When you take and you cut, if we were to cut right along there and take the bases off and open it up, what shape would you have? Think about that for a few minutes. What shape would you have? And we'll talk more about that here in a second. All right, let's identify the following here. What is the shape? Well, it isn't curved, so our choices are either prism or cylinder for what we talked about so far. And so this would definitely be a prism. And with our prism, what type of prism is it? Well, it looks to me like we have bases that are rectangles. So this would be a rectangular prism. And with that rectangular prism, possibly those could even be squares. So if they are all squares, it's going to be a cube. Our vertices are all of the corners where three bases meet. They intersect. So we've got vertices and they're points. So we just label them with the capital letter A, B, C, D, and so on. Those are all vertices. Our faces are all either rectangles or squares, whatever that you want to say that they are there, but we still name them the same way. If I want to name this front face, I'm going to do this so you can get a better idea. This guy right here, you remember you name it in order. So I'm going to start with A, so I can either call it A, D, H, E, or I could call it A, E, H, D, one of the two. Doesn't matter, as long as you pick, and there's also other names if you started with E or H. As long as you start with one and you work your way around. Okay, that's one face. Also, there's a face down here on the bottom that you maybe can't see very well. It looks like, remember with the three-dimensional figure, okay, it looks like it may be a different shape, but they are all the same shapes. It's just the way that we can see it. So I'm going to call this one E, F, G, H. And then there's more faces there that you could name. Edges are segments, so remember how we write a segment. If I want to do that segment right there, it's AD, and I put a segment bar over the top. If I want this segment back here, it's BC, and I put a segment bar on top. Again, there's a lot more edges there, but I'm not going to name them all. Okay, some more vocabulary. We're going to talk about altitude. Altitude is a perpendicular segment joining the planes of the bases. So our altitude is also called the height. So anytime you see altitude and height, know that that's the same thing. Basically what it is you go to the highest point and you drop a perpendicular line down. See, now that we have our 90-degree angle, we know that that is our height or our altitude. So you're always looking for that 90-degree angle. Prisms and cylinders we already talked about. They have two congruent parallel bases. Remember, of a cylinder, it's circles. Of a prism, it can be squares, rectangles, any polygonal shape. A lateral face is not a base. So our lateral face would be everything that is not included in the shaded part. The shaded parts are our bases. The white parts, or the clear parts, are our lateral faces. A lateral edge is not the edge of a base. So our lateral edge has to be, like on this one, it has to be here on the sides. It cannot be one of these going horizontally, in this case, this way, or one of these. So it can't be those. It can only be what's in the green. That's a lateral edge. Remember that for what we're going to do next. Okay, what we're going to do is we're going to find the lateral area. So the lateral area is the area of all the lateral faces of a three-dimensional figure. The key thing to remember is it does not include the bases. So notice we have a rectangular prism here. We identified our bases there by their shaded. What we want to do is we want to find the area of everything that's not shaded. Same thing here. Okay, we have this shaded, the two circles, so we want to find the area of the rest of the cylinder. Same thing here. We have the two triangles. Those are our bases. We don't want to find the area of that. We just want to find the area of the parts that aren't shaded. That's lateral area. So how do we find the lateral area? Well, of a right prism, here is the formula right here. So make sure you get this written down. The lateral area, which is represented by L, of a right prism. What it means by a right prism is it means there is a 90-degree angle somewhere. In this case, it would be right here, okay, or right here. Trust me, that is a right prism because it's straight up and down. It's just we have it turned sideways in the picture. But the lateral area is equal to the P, which is the perimeter of the base, times H, which is our height. So H is our height. So what they did was they took one of the bases, which was the triangle. They found the perimeter. Remember, you find perimeter by just adding things up. So we're going to add up A plus B plus C. When we get A plus B plus C, then we times it by the height. So lateral area equals the perimeter of the base times the height. For a cylinder, we have the perimeter of the base. Well, remember the base here is a circle. So if the base is a circle, then we know we're talking about circumference for our perimeter. So we find the circumference of the cylinder, and that's represented by 2 pi r, and then we times it by the height. So the same thing is that we found basically the lateral area equals the perimeter of the base, which remember in our case it's a circle, so it's a circumference, times the height. So it's still the same formula, we just have to use a different thing to find the perimeter of our base. Okay? Now, let's find the lateral area of this rectangular prism. Well, first of all, the P, remember, stands for perimeter of the base. Here's our base. I usually, with a rectangular prism, I look at what it's sitting on because really we could call any of those the bases, but I look at where it's sitting on. And it's sitting on this guy right here. Well, I know if it's rectangular that this is 9, so this has to be 9. If this is 7, this has to be 7 by properties of a rectangle. So I figure out what the perimeter is. So that would be 9 plus 9 plus 7 plus 7. 9 plus 9 plus 7 plus 7. So that would be 18 plus 7 is 25 plus 7 is 32. So 32 goes there, times the height. The height is 14. So 32 times 14. So our lateral area would be 448. Our unit's still squared because it's still area. That's how you find the lateral area. Perimeter times the height. Okay? So how do we find the surface area? Surface area, people get this confused. Surface area is all of it, all the surface. What if I wanted to wrap a present? I wouldn't just wrap certain sides. I want to wrap the whole present. Okay? So when we're talking about surface area, it's all the faces and all the curved surfaces. Okay? So we have, on this, we'll have 6 sides to cover. This will have the 2 circular bases plus that curved surface. And this will have, our triangular prism will have 1, 2, 3, 4, 5 sides to cover. Now, with the surface area, if we're already finding the lateral area, which is everything but the bases, all we'll need to do is then find the area of the bases and add it to it. So, what we're going to do on the surface area of a right prism is we're going to do the same thing that we did before. Notice, this is our lateral area, the perimeter of the base times the height, but now we're going to add B, which is the area of one base. So the area of one base. Well, because we have 2 of them, we're going to multiply that B by 2. So our surface area is equal to the lateral area plus the area of the 2 bases. So all we did was we added this to it, which is the area of the 2 bases, to our lateral area. That's the right surface area of a right prism. Okay, the surface area of a cylinder. Well, notice area right here. Here's the area of the base is a circle, so it's pi r squared, and we're going to times it by 2. So our surface area formula is 2 pi rh plus 2 pi r squared. The lateral area, which would be that, it would be the curved surface, plus 2 times the area of the bases. Make sure you're writing these surface area formulas down. All right, so let's do an example. First off, we determined that that's the surface area of a rectangular prism. They gave us the formula right there. So let's find the perimeter of our base. Well, I'm going to go with it. This is our base, because that would be what it would be sitting on if it was down there at the bottom, if we could see it. So I'm going to find the perimeter. I know that if this is 6, this is 6. If this side is 4, this side is 4. So I'm going to add those up. Well, that's 6 plus 4 is 10, plus 10 is 20. So I've got my surface area equals 20, okay, times the height of the whole figure, which the height of the whole figure is right here. That basically the height is the distance from base to base. Well, here's the first base, here's the second base. What's the distance between the two? 9. Plus 2. Now I got to find the area of the base. Well, remember with the area of the base, it's a rectangle, and we know that the area for a rectangle is base times height. And when we're talking about base in this formula, we're talking about the base of the 2-dimensional figure, not the base of the whole 3-dimensional figure. Okay? Big B and little b are 2 different things. Big B, remember, is the area of the base. Little b is the base of the base. It's kind of confusing. But just remember, you got to multiply the 2 together. So it'll be 6 times 4. So we have 20 times 9 is 180. Plus 24 times 2 is 48. Add those together, and we get 228. It didn't give us a unit, but let's just say it was feet, so it would be feet squared. All you're doing is plugging into that formula. All right, let's now find the surface area, or we're going to find the lateral area and the surface area of a cylinder. Now remember I said let's figure out what shape that curved figure actually makes. So if you were to take a piece of paper and make a cylinder and then open it back up, well, what shape is that? Well, it's a rectangular piece of paper. So the actual lateral area that we're looking for is the area of a rectangle. Well, in order to find the area of a rectangle, we need the height of the rectangle. So picture that this curved part is the area of a rectangle. So we've got our height, okay? We need the base, which if you look at the base is actually the circumference of our circle. So that's why we get the lateral area is 2 pi r times the height. 2 pi r is that perimeter of the circle, which is also called our circumference. So we're going to take 2 pi. Now our radius, be careful on this, they like to do this to you. Our diameter is 10, so our radius is 5, times the height is 6. Okay? So our lateral area would be 2 times 5 times 6, which is 60 pi. And it's centimeters squared. Remember, this is our exact answer. If we wanted our answer in, like to the nearest tenth or something, remember you would take 60 times 3.14. So when we take 60 times 3.14, we get 188.4 centimeters squared. So either one of these answers work. It just depends on which one they ask you. Remember, that's exact. That's like to the nearest tenth. Okay, so there's our lateral area. Well, we're halfway there because now all we need to do with our lateral area is add the area of the two bases. Well, I'm going to go ahead and write the whole formula out. 2 pi RH plus 2 pi r squared. Well, we've already got 2 pi RH. And let's go ahead and leave it in terms of pi here. So it's 60 pi plus 2 times pi times our radius again was 5 squared. Oh, that should be S. Sorry. Go back here. This should be S for our surface area. All right, so we've got 60 pi representing our lateral area plus 5 squared is 25 times 2 is 50, so it's plus 50 pi for our area of our two bases. So we just add those together. So we get 110 pi centimeters squared is our surface area. Or, again, if they want it to be, if they want it rounded, take 110 times 3.14, and we get our surface area is 345.4 centimeters squared. Again, either one of these answers work, just depends on what they ask you for in the direction. All right, our last example is finding the surface area and lateral area of this prism. Well, let's determine what the prism actually is. The prism is a triangular prism. Remember, we name it by its bases. So let's find the lateral area first. We have to find the perimeter times the height. So our lateral area, our perimeter is what? Well, it's of this triangle. Notice we have our two sides of our triangle here, and then we've got to drop that 17 down. So it's going to be 8 plus 15 plus 17. 8 plus 15 plus 17, and we get 40. So our perimeter is 40 times our height is 4. So our lateral area is 160 meters squared. Okay? So now we have 160 meters squared. What we need to do is we're going to take that, I keep doing that L, we need to put an S there. We have our surface area equals our perimeter times our height plus the area of our bases. Well, that would be 2 times, well, how do we find the area of a triangle? Remember, we take 1/2 base times height. Again, that little b is different than big B. So we're going to take our surface area. We already found out what pH is, and that's 160, plus 2 times 1/2 times the base Notice it's a right triangle, so it's going to be easy to find which one's our base and our height. It's where they connect to make the 90-degree angle. So these two right here are our base and our height. So that'd be 8 times 15. So we have 160. 2 times a half would just cancel out. So really we have 8 times 15, which is 120. Now we just have to add those two together. So that would be 280 meters squared. That would be the surface area of the prism. Again, all you have to do with these is be able to plug them into the formulas that are provided. Make sure you get these formulas memorized. That's all we have for today, so make sure you write a summary and come up with a good question, either about the about any of the examples or just a question you still have about the notes, or if you want to make up your own problem, you can do that also.